In this problem, we are looking at the application of Avogadro's law, which basically says that certain certain number of moles of any gas occupies the same volume. So here is the problem. The problem states that in a mixture, there is CO2, which is 40 moles, and water vapor 4 moles, nitrogen is 200 pound moles, and this gas is going or leaving the stack at 150 degrees Celsius. Okay, so we are asked to calculate, we're looking at calculating the volumetric flow rate and also the partial pressure of water vapor in this mixture. Okay, these are our objectives. So let's take a look at it. Whether it is CO2 or water vapor or nitrogen, all gases occupy same volume. So we can simply add these and come up with 40 moles of, and there is also, in addition to this, let me add one more gas here, which can be, typically we would also have oxygen. So we can add oxygen also to this to make it more realistic. Oxygen, let's say 10 moles. Okay? 10 moles, pound moles. So now the total number of moles that are flowing would be 10 plus 40, 50 plus 4, 54, and 200. So 254 pound moles of gas is flowing. So we all know that irrespective of the species, each mole occupies certain volume. All right, so we can calculate the volume occupied by 254 pound moles of gas. And we also know from Avogadro's law that each pound mole at standard conditions occupies 359 cubic feet. All right, so now we can easily calculate the total volume here. Okay, I want you to try this and then let me know what the volume is. So this volume will be feet cube. All right, this feet cube is at STP, okay, standard temperature and pressure, which in this case will be 0 degrees Celsius, and pressure would be 1 atmosphere, right? Now, the gas is actually leaving at 150 degrees Celsius, so we need to correct the volume to this temperature. So now 254 times 359 would be, here is where,
So you probably just want to say that again. So 259 plus whatever that was.
okay, all right. So this would be 259 times 359 is equal to 91,186 feet cube, right?
We're on 254, right?
Yes, 254, yeah, that's right, 254. Okay. 254. So 254 times 359 will be 91,186 cubic feet at 0 degrees Celsius and 1 atmosphere pressure. So now we take this volume, 91,186 feet cube, and we are correcting to the temperature. All right? The temperature at which we are is at 0 degrees Celsius, and we are going to 150 degrees Celsius. And so this would be at 0 degrees Celsius. Again, we have to convert these into Kelvin whenever we are talking about energy. So we're talking about 273 here, Kelvin. And now we are going to 273 plus 150. Okay, this both will be in Kelvin, so these things will be canceled. and you get the volume at 150 degrees Celsius. So this would be
423. Oh, divided by
423. So the volume is coming out to be 141,288 feet cube. All right, feet cube. This is the flow rate. This is the volume that is flowing out at 150 degrees Celsius and 1 atmosphere pressure. Okay, 1 atmosphere pressure. So that is what we are after. However, the volume can be in meter cube. Let's say if I asked you to calculate in meter cube, so we need to convert this again. I just want to practice a little bit here. If we look at 1 feet cube is equal to 0.28, let's say approximately 0.283 meter cube. So now if we have 141,288 feet cube, and we need feet cube down below here, 1 feet cube equal to 0.283. I'm sorry, this should be 0.023, So this would be the volume in meter cube now at 150 degrees Celsius. Okay, so that is the volume. This would be 3,998. So 3,998 meter cube at 150 degrees Celsius. That is the volume that we are after now. Okay, let's look at the second part, partial pressure of water vapor. Partial pressure is the pressure that is exerted by water molecules in the total volume, in the total pressure that is exerted by all these gases. So all these gases together are 254 pound moles, of which 4 pound moles is the share of water vapor. So the fraction, mole fraction, is 4 over 4 pound moles divided by 254 pound moles. This would be your mole fraction of the pressure that is exerted by water vapor in the total. So the total pressure exerted by all these 4 gases and the pressure exerted by water vapor is what we need to look at. This would be proportional to this and 4 pound moles. So if we calculate this, it would be 0.0157. So basically, this is the fraction of the pressure that is exerted. The pressure at which the gases are going out is 1 atmosphere. So if we multiply this by 1 atmosphere, the partial pressure exerted by this gas would be 0.0157 atmospheres. This would be the partial pressure. Or in other words, if we want to calculate the percentage of the pressure that is exerted by this, by water vapor, it would be you multiply this by 100 and it will be 1.57%. Okay, this would be the partial pressure. This would be not partial pressure, this would be the percentage of the total pressure that is exerted by water vapor. Partial pressure is this. All right, I hope this is clear. That's about it for this problem, I guess.